In this video, we'll be looking at Chapter 19, Section D on the arithmetic mean, geometric mean inequality. Now maybe you've seen these means before, but let's refresh our memories. The arithmetic mean of two non-negative or positive numbers is a plus b, or the sum of the two numbers, divided by 2. Whereas the geometric mean is the square root of the two numbers multiplied together, or the square root of AB. And again, A and B have to be non-negative. Now this would also include 0, as 0 is neither negative or positive. Now there are some interesting properties of the arithmetic and geometric means when we compare them to each other. And we could do a little bit of a study, but I'm not going to take the time in this video because your textbook does it pretty well. But if you plug in values of a and b, remember they have to be non-negative, we see that a plus b, or the arithmetic mean, is always greater than or equal to the geometric mean. And the case where they're equal to is when a equals b. Right? So if a and b are equal, then the arithmetic mean and geometric mean are equal. But otherwise, the arithmetic mean is always bigger. And we can use this property to help us solve some optimization problems. So let's take a look at an example problem. In this problem, we're asked to show that the sum of a positive number and its reciprocal is never less than 2. Now we might need to define what a reciprocal is if you've forgotten, but let's replace a positive number with a variable. We'll call it x. Well, if x is a positive number, then its reciprocal is 1 over x. So these are my two numbers. I have x and 1 over x. Remember, the reciprocal is a number underneath 1. So we know that x is positive by definition, therefore its reciprocal must also be positive. Therefore, we can use the arithmetic mean, geometric mean inequality. Right? We'll have x be our first number and 1 over x be our second number. So the arithmetic mean is simply the sum of those two numbers divided by 2. And the geometric mean is the square root of the two numbers multiplied together. So hopefully you can see pretty quickly on the right hand for the geometric mean that this is going to simplify to the square root of 1, which we all know is 1. So now using the inequality, the standard form, which again is a plus b over 2 is greater than or equal to the square root of a times b. And now we plug in our numbers. We have x plus 1 over x times, or divided by 2, is equal to the square root of x times 1 over x, which is simply 1. I'm sorry, greater than or equal to 1, because this is an inequality. Now, using the properties of inequalities, where I can multiply both sides by 2, I can rearrange this so that I get x plus 1 over x is greater than or equal to 2. Well, I've just proved the statement above. Remember what the statement is. It seems to have disappeared, but the statement was show that the sum of a positive number and its reciprocal is never less than 2. Well, what we've shown is that the sum of a number and its reciprocal, which is on the left-hand side, is greater than or equal to 2. That means the minimum value for this expression on the left has to be 2. Let's take another look at an example. Here we have an enclosure, or we want to make 3 enclosures actually, of identical area, and we have 600 feet of fence available. So the question is, what's the maximum area that I can enclose here and still get identical rectangular areas? So if looking at the labeling here, we have one enclosure has a length of x and a width of y, so the area for each enclosure is simply x times y. Also, if we add up all of the sections of the fence here, we see that we have 4 x values and we have 6 y values. And so that's the total length of fence that I'm using here. So we have 4x plus 6y, and that has to be equal to 600 feet because that's the amount of fencing that we have. Now both 4x and 6y are non-negative because we're talking about fences here. We can't have a negative fence length. So we can, and we have two numbers, so let's use the arithmetic geometric mean inequality here. Okay, so I have 4x plus 6y, and the arithmetic mean of those two numbers is the sum divided by 2, and that has to be greater than the square root of their product. But we know that 4x plus 6y is equal to 600, so I can substitute that into the equation, or the inequality. So I have 600 divided by 2, and doing a little bit of simplification over here, we have the square root of 24 times xy. We're going to keep going with the simplification here. So we have 300 is greater than the square root of 24 times xy. And now I can square both sides of the equation, and I get 90,000 is greater than or equal to 24 times xy, and therefore I have 3,750 dividing both sides of the equation by 24 is greater than or equal to xy. But remember that xy is also equal to the area of each enclosure, so the area is less than or equal to 3,750, and therefore our max area is 3,750.